Okay, so you guys should have already finished the notes, and from what I've gotten from you guys, it seems like you didn't really have any issues with it. So good deal. But also, this is the first time I'm like recording myself just talking to a camera. So if I get a little shifty-eyed, it's because it's really weird. So anyway, um, so what I want to tell you about these solubility graphs and stuff like that is you already know this intuitively. You just may not have seen the graph of it. Okay. So what I mean by that is if I have a cup full of iced sweet tea, okay, and I'm like, it's not sweet enough. I'm gonna put some more sugar in it. What's gonna happen to that sugar? It's gonna fall right to the bottom, right? Because it doesn't mix in well with cold things, which means the colder the temperature, the less soluble it is, right? Okay, so it doesn't want to go into the solvent. Okay, but if I have boiling water and I put a crap load of sugar in there, well, it's okay. It's going to dissolve in, right? Because as temperature increases, solubility increases too, okay? And now I'm going to show you this, okay? Just put a graph to what I just said. So one thing we should already know is 0 degrees Celsius is freezing and 100 degrees Celsius is boiling, okay? That's why we're talking about it on this scale, okay? So if I have ice water, okay, or water at 0 degrees Celsius, or ice, if you will, how much sugar can I get in there? None, right? Okay, so our dot is going to be here. If I warm it up just a teeny tiny bit, it's still really cold. I might get a little bit of sugar in there, okay? A little bit more, I'll be able to get a little bit more sugar. A little bit more, a little bit more sugar. And then now I have boiling water. I'm going to be able to put a crap load of sugar in there, right? Okay, so our graph's going to be like way up here, okay? So our graph will look like this, right? Which is really similar to those solubility graphs that you were looking at from the worksheets, right? Now this graph is not accurate at all, okay? I just want you to see the correlation, okay? So now I'm going to go ahead and flip through a couple of these and answer a couple of the questions so you guys can just kind of see what I'm asking of you, okay? Okay. I have to move my pen away from this, otherwise this other mouse doesn't work. Okay. Okie doke. So let's look at this. Now one thing that I will say is if you need to color code this graph, then color code the graph, you know? Whatever you need to do to help you, get it, okay? So let's talk about this real quick. So let's see, number 3 says, which two substances have the same solubility at 25 degrees Celsius? Okay, so I go to 25 degrees Celsius, go up, well, look right here. I have two substances that cross. What is going on? Oh, I have my eraser on. Right here, okay? And that is potassium nitrate and sodium chloride. Okay, so again with the eraser. Potassium nitrate and sodium chloride. You guys should know the formula for that. Okay, which substance's solubility changes the most from 0 to 100? This will naturally be the one with the greatest curve. Okay, so potassium nitrate. Okay, which solubility changes the least? 0 to 100. Look at the sodium chloride. It is like a straight line, okay? It does not matter how hot you get sodium chloride salt, right? It was weird saying it. It's salt. So this, according to this graph, it doesn't matter if your salt is barely above freezing or boiling. You can only put so much salt in there, okay? Okie doke. So let's see. At what temperature does potassium iodide have a solubility of 150 grams per 100 cc's? Okay, notice. I said cc's. Where have you ever heard that? Have any of you watched like Cows or Grey's Anatomy or some other medical show? There's so many. And they're like, somebody's dying and they're like, quick, pump them with 50 cc's of epinephrine, okay? A cc is a milliliter, okay? Cc means cubic centimeter, right? So centimeters cubed is the same thing as a milliliter, okay? So now you have a visual and a connection with cc. So if I say that, please know that I mean cubic centimeters, okay? So all of these graphs are grams per 100 cc's, or grams per 100 milliliters, okay? Okie doke. So let's see, you have what temperature? Okay, so we're gonna find 150 milliliters, okay? Potassium iodide, 150 right here, boom, here's our line. Straight down, which is about, I don't know, 12.5, 13. I'm not gonna be crazy about it, okay? Let's say about 13. Good? Okay. Let's see. You have a solution of potassium nitrate containing 140 grams at 65. Okay. Saturated, unsaturated, or supersaturated. Okay, so this is in your slides, but just in case you don't really understand, it's saying that, so we're talking about sodium nitrate. So it's saying at 30 degrees, sodium nitrate can comfortably and like at its max hold about 95 grams per 100 mils. Okay, so if I have 100 mils of water at 30 degrees and I dump 150 grams of sodium nitrate into it, it's gonna fall out. It's gonna be on the bottom of the container. Like the water can't hold it. Okay, so if it's above this, it's considered supersaturated. If it's on it, it's saturated. If it's below the line, it's unsaturated. Okay. Okay, so 140 at 65. Let's see. 65. At 65, it can hold about 130. Okay. So if it can only hold 130, and this is saying we have 140, then it's going to be super saturated. I don't know why this box keeps popping up. Maybe I can make it stop eventually. Okay, that makes sense. Okay, so okay, a solution of potassium iodide contains 70. Well, what? Solution potassium iodide at 70 degrees was 200 dissolved solute. Okay. It's allowed to cool. At what temperature would crystals start forming? Okay, let's go look at this. Potassium iodide, here we go. At 70 degrees, here we go, contains, get out of here, contains 200, okay? While it can actually hold about 240, 245, okay? But it's saying there's only 200 in there. But they're cooling it down, okay? So here's what you guys actually know about this. Have you ever been to like the fair or like a candy store and gotten those little rock candies on a stick, which is just crystal sugar on a stick? Okay, well, how they do that is they get water super, 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 super hot and they put a ton of sugar in there, okay? Like they super saturate the solution, okay? And then they put a stick in the water and they cool it down super fast. And when they do that, the sugar will stick to the stick, but it forms these really intricate, really cool crystals, okay? And that's what's happening here too. So basically, we're going to cool it down and we're going to form crystals, and that's called falling out of solution, okay? So when we cool it down from 70 degrees, it's saying contains 200. So we need to see at 200, so this is its comfy spot, right? Okay, so this is saying at about 44 degrees, it can hold 200, but any less than that, stuff's going to start falling out of solution. So at what new temperature would crystals begin forming? It's going to be right around 43 degrees, okay? Does that make sense? Okay, I'll move on a little bit. Make sure, like I said, make sure you're using the right graph. That would definitely throw you off. And this is a big mess, okay? So if you need a color, do it. Might help. Okay, let's look at this one. How many grams of, I don't know how to do this. Let's see if I can make it go away. Oh, I did something crazy. Okay, just kidding. Okay, so how many grams of ammonium chloride at 50 degrees Celsius? So we're gonna find NH4Cl. There we go. On 50 degrees. Boom, boom, 50 grams. That makes sense. You're literally just reading this graph, okay? Okay, which is least soluble in water at 10 degrees? So we're gonna look at 10 degrees. Right here. Okay, KClO3. KClO3. Okay, we'll get some more difficult ones. How many grams of Ki will saturate water at 20 degrees Celsius? Okay, remember saturated is on the line, right? Okay. So if we're looking for Ki, which is at the very top, it's the most, it's incredibly soluble, okay? So 20 degrees, we're gonna all the way to the top. How many grams? Which is about 145, super soluble, okay? Okay. I feel like these are no big deal. Okay, let's talk about this one. If 25 grams of NH4Cl is dissolved at 50 degrees, how many additional grams would be needed to make the solution saturated at 80? Okay, so let's go to NH4Cl, which is 80 degrees, which is right here. Okay, it can hold about 65, and it says it has 25. So the difference between 65 and 25 is 40 grams? Yeah, quick math. Okay. Okie dokie. Super saturated. Okay. You can just write on. Okay, let's see. 55 grams NH3 at 20 degrees Celsius. So here's NH3. We're at 20 degrees. Boom. It can hold about 53. So I would say it is super saturated. Super saturated. 10 grams of selenium sulfate at 10 degrees. Selenium sulfate, 10 degrees. Look, here we go. Under the line means unsaturated. Okay? Good? On the line means saturated. Above, super saturated. Okay? Okie dokie, let's talk about this one. A saturated solution of KNO3 was made with 200 grams of water. Okay, the solution was cooled to 20. Okay. So, at 50 degrees Celsius, KNO3 has 200 grams. That is a ton of water. Oh, okay. So this is saying, I guess we're not supposed to look at this graph because it specifically tells us that it is saturated. So let's assume that, okay? Let's ignore the graph for a second on this one. So a saturated solution, which means it is holding as much as it can hold, was cooled to 20 degrees. Okay, how much KNO3 precipitated out? So let's look at 20 degrees and see how much KNO3 can hold. It says about 33, so we'll do 200 minus 33, which is about 67 grams. Okay, I don't really like this question because you can't really find the first part. I don't like that, but that's okay. KNO3? No, sorry. Thought I saw something that I had done wrong. Okay, so I think it's pretty reasonable. If you guys are still having problems with the graph, it's going to be really hard if you're having to read the question, flip back to the graph, okay? Like, you need to be able to see them side by side. And if you just can't, then, I'm sure you can figure out, maybe take a picture with your phone or something so you can look at it alongside your questions. But, like I said before, this is stuff y'all know. You just haven't seen it quite this way before. So, you can do it, okay? That is all I have. It was awkward for me. I hope it was just as awkward for you, but I want to say that it will get better, but it probably won't. So we'll get through it, okay? So I'll talk to you guys later.